Good afternoon. Welcoming you back to our lab session today. As per what your HOD had told, that today all three sections would be here. Kindly confirm it. All of them are here. That is A, B, and C. Or is there a D section also? I don't know. D, E, and F thereafter. Aman Gupta, tell me.
It's A, B, and C, sir.
Great, thank you, Nishiban. So first we will do practicals for both of them separately. First, since day before yesterday or so, the B section had done on creating a token. We will start off today for the A and C section. Kindly listen to me very carefully. It is only for the A and C section. The B section students may listen to it. It would be an additional revision for you guys. First, I'll tell you what is the practical which A and C section has to do, which will be nothing but creating a small little smart contract, or by creating a token. That is what we will do. We will get into creating our first smart contract. And for the B section, we will do it subsequent to this, which will be creating a simple blockchain, which you had missed up, and your one experiment behind A and C. So commencing with the one for A and C, what we will do, we will introduce this solidity language. Although we had repeated this in the class, perfectly fine. Let it be an additional revision for you. And thereafter, we will create a smart contract. Solidity, friends, is a high level language that was designed for writing smart contracts. And it is something similar to this Python, C++, JavaScript, all these. You must be knowing that in a traditional, how does a traditional programming language system look like? You must be well aware of it. In any case, just to brush up your memory, since you are able to see a blank screen in front of you, which is the canvas, I'll write for you how a traditional programming system is. You have got the code editor, then you have also got the compiler, also you have got the runtime. I'll just write it as RT. These three things are connected to what is called as a local storage. This is what is local storage. Here you have got a source, and apart from this you have got your executable, and apart from this you have also got your programming data. So these are three blocks in this local storage. The executable and program data send and receive data from each other. So I'll put this way, and this whole of this local storage, I'll put it in a box. This is an enclosure for this, and this interacts with what is called as the remote memory. In the remote memory, on top you have got runtime, and down below, which is the remote storage, you have got two components: the executables and program data. And this whole thing is what forms the remote storage. And this, the executable from the local storage interacts with the executable from the to the remote storage. This is what is a traditional programming system. Now when you get into this Ethereum programming system, it is slightly different. I'll just redraw for you how an Ethereum programming system looks like. An Ethereum programming system has got basically three modules. The first, I would say, it is the contract source, which is the local storage. This thing I put it in an enclosure. And apart from this, you have got distributed transaction pool. It is distributed transaction pool, which contains the contract creation transaction. Will you be able to remember it, or is somebody writing it? I'll again repeat it. The Ethereum programming system has got CS, which is the contract source, then LS, which is the local storage. Basically, the local storage contains the contract source. And the next block is what is the distributed transaction pool, which contains the contract creation transaction. And the last block is what is the distributed blockchain, which contains two entities: contract executables and program data. This program data intermingles with the contract executables. So we have got three blocks of this kind in a Ethereum programming system. We've got three blocks of this kind. Here, the contract creation transaction interacts with the contract executable. And on top of this, for the first block, you have got what is called as the local memory. And in local memory, you have got two subsets. One is the code editor and the other is the compiler. The code editor interacts with this local storage, and this compiler receives information from the local storage. And this compiler also interacts with the distributed transaction pool. Now, on top of this distribution transaction pool is what rests the miner. This miner receives information from the distributed transaction pool, as well sends his messages or what he has extracted to the contract executable. Now, in our last block, we have got the miner for transaction, and we have got local memory. Local memory receives instruction from the contract executable, and the miner for transaction receives information from the program data. So this is what is an Ethereum programming system. Is it clear, or somebody wants another one quick brush through of this? Don't worry, we have not drawn this kind of cartoons for your block or your section B. It was verbally explained to them. That is why I requested, if section B wants, you may also kindly listen to it. You will be benefited. Is it clear to you? Please tell me yes or no.
Sir, repeat once.
Okay, fine. See, here what I'll do, I'll create for you a new canvas. See, you have got in the Ethereum programming system three blocks. The first block, I'll first draw it as a block. This is my first block. This is my second block. And this is my third block. In the first block, which is nothing but the local storage. The first block is the local storage, which contains the contract source. And this contract source receives messages from the code editor. It receives messages from code editor. Also, this local storage feeds to the compiler. This compiler also interacts with the second block, which is the distributed transaction pool. And this distributed transaction pool has got contract creation transaction within it. This contract creation transaction, comfortably what it does, it sends messages to the miner, and this miner also sends a message to this entity in the third block, which is the distributed blockchain. And the entity in the third block, who is this entity? He is the contract executable. This contract executable also gets instruction from contract creation transaction from here. Now, this contract executable also receives instruction from another block which is below it, which is the program data. So program data feeds this contract executable. This contract executable feeds the local memory. And along with the local memory, you have even got miner. Why is this miner? Miner is for transactions. And this miner for transaction gets information from the program data. So this is what is an Ethereum programming system in very, very simple words. For all those who are interested, you may draw it down, because we are putting a little bit of efforts to make it comfortable for you. Fine. Can we go to the next one? because we got 2 sections to complete our practicals. Tell me, can we go to the next one? If you're, is anybody drawing this?
Yes, sir. Drawing.
Okay. Chalo, let's go to the next one. Have you completed?
Yes, sir.
Yes, sir.
We will first now draw up our first smart contract. See, when you have your first smart contract, they need to, we know that this first smart contract are robots which are which control the Ethereum address, and these smart contracts can receive, hold and send ether. It can also receive, hold and send tokens. It can also execute functions from any other contract or robots. And also the smart contract can broadcast transactions to the Ethereum blockchain. Basically, for example, a transaction that calls a function that changes the contract's owner. So these are the 4 things what a smart contract will do. Now we know one of the first simplest blockchain, or the first, when you speak of this fully fledged cryptocurrency which is created in a blockchain, that is one of the things which you can do with a blockchain is what you do, you create your own cryptocurrency. And this creating a fully fledged cryptocurrency, which otherwise is called as an altcoin, which means implementing a few points. I will first draw you the structure of what an altcoin is. Now, if you say this is the altcoin, which I say, let me say this block is the altcoin. This block is the altcoin. You can write here altcoin blockchain. This altcoin blockchain contains a genesis block, which is the first block. This is the genesis block. This genesis block feeds another block. So let me say block 1. This feeds block 2, and this goes on till block n. How many ever blocks are there? And where does this receive information from? This altcoin blockchain, definitely it receives information from the wallet. That is, it sends information to wallet as well as receives info from the wallet, and this interacts via a web explorer. That is, this altcoin interacts via a web explorer. This is basically the simplest infrastructure for an altcoin. Now, sometime back I said you can do a few things with a blockchain, and one of the simplest thing is creating your own cryptocurrency, which otherwise is a fully fledged cryptocurrency called as altcoin. You can write it this way, it is ALTCOIN, altcoin. Now, this means implementing a few points. The first, a wallet, which is capable of coin operations, such as maybe writing transactions and reading transactions, and also capable of mining to create new blocks. The second is a blockchain with a genesis block, that is the first block in the blockchain. And the third, a block explorer to display blockchain transactions. So you may kindly write it down. See, one of the few basic things that you can do with a blockchain is create your own cryptocurrency, which is nothing but altcoin, which means implementing 3 things. The first is a wallet, which is capable of coin operations, such as you can say writing transactions and reading transactions, and also capable of mining to create new blocks. Have you written the first point? Tell me why have you gone silent? Have you written the first point? We said an altcoin, which means implementing few points. The first one being a wallet capable of coin operations, such as writing transaction and reading transactions, and also capable of mining to create new blocks. Tell me if you completed this.
Done, sir.
The second is a blockchain with a genesis block. Which is the first block in the blockchain. Done?
Yes, sir.
And the third is a block explorer to display blockchain transactions. Have you done?
Yes, sir.
So these are the three things which means implementing a fully centralized blockchain. Now, see, in the context of cryptocurrencies, a wallet is nothing but, we know it can be a hardware wallet or a software wallet. But either of them is a software program that allows you to send and receive coins. And technically speaking, a wallet stores private and public keys and interacts with the network. Now, we said this is what is a wallet. Now, the one more small thing you need to understand with regard to smart coin is you can create what is known as a token, which is a cryptocurrency that runs on Ethereum's infrastructure. And your token will be able to operate using a standard Ethereum wallet, record the transactions on Ethereum blockchain, and be visible in the Ethereum's block explorer. So what we will do, let's have a look at the most simplest infrastructure of a token. When you speak of a token, that is, let me say this is Ethereum blockchain. Here in the Ethereum blockchain, we know there are 4 blocks. The first is the Ethereum Genesis block. The second is I will have a block here. Then again, I will have one more block here. But this third block will be with a token contract. And finally, another block. So these 4 things will form up what is called as an Ethereum blockchain. So these are the 4 things in an Ethereum blockchain, and this Ethereum blockchain interacts with up and down with the Ethereum wallet. If this is my Ethereum wallet, it receives as well as sends to an Ethereum wallet. But all this we know is through an Ethereum web explorer. So this is what is the infrastructure of a simple token. In the meanwhile, while you draw it, please also listen to me. There are some Ethereum wallets which perform token operations for you. So it will write token transactions to the Ethereum blockchain and will also be capable of reading them. The transactions which are related to your token will be recorded in the Ethereum blockchain, and you will need Ether to pay for recording them. Please understand, these Ethereum block explorers will take care of displaying transactions related to your token, which means that you will not need to create a fully fledged infrastructure. See, in any Ethereum blockchain, you pay for the computation because you are using their network. This is measured using what is called as gas. This is measured using a concept called gas. And for every operation a smart contract can perform, there is a specific cost, say some 6 gas, 20 gas, 30 gas, and each unit of this gas has also what is called as a gas price. This gas price is set in a unit called GWEI. It is set in this GWI and directly translates gas to ether. And it is important to note that gas is not a currency by itself and only a measure of computational effort. So what we will do, we will right away, let me just keep my digital pen beside, and we will create a simple token. And to create a simple token, we will do it. You must be knowing how I'll create a simple token. I will do it using Ethereum, using Solidify, and Remix Solidify I'll be using to create this. So I share another screen with you. So let me say Solidify, Solidify Remix. I will be using Remix Solidify to create this Ethereum for you. So I'll click on this Remix Ethereum IDE. Let's get into this. Wait for a few seconds for Remix to load up. It's a wonderful IDE. Have you got into this?
Yes,
Yes,
sir.
sir.
Okay. Please click on New File here, which you see, New File. A file will be opened on the left hand side. Give this file a name. I say it is a simple token. Now, this simple token, you will have a file created by the name of simpletoken.sol. Open this, because the simple token day before yesterday I had created for the other class. So I'm creating another one, simpletoken1.sol. We will create a small little token. Are you all at the screen?
Yes, sir.
Yes, sir.
And the simple token I create, I'll give it a name, as I'll say the contract which I want to create is my token. And here I'll give a curly brace. And understand, all comments in this Solidify is written after a slash and a star. Or if you're writing the comment on the same line, it is double slash. So the first thing, I'll write a comment which will be slash and a star, which will say this, which I want to say, that whatever comes to your mind you can write here. The minute you write anything after a slash and a star, it is not executed. What I am doing is I am creating a contract data, which is nothing but an array with balances and initial number of tokens. And once again I close it with a star and a slash. Now after this, when you write anything between this, it is not executed. Whatever comes to your mind you can write. Then what I do, I map the address. For mapping the address, I'll say mapping, which I'll say my address, which is, and this address is an unsigned integer 256, and I close my bracket, and I'll say this is the public balance of, and I end it with a semicolon. Then see, if you don't put semicolon, the line doesn't get terminated. Like this, what you do in C, C++. Then I give an initial supply of this token, thereby making it public. So I say unsigned integer, which is my initial supply. This is nothing but, let me say, 1 followed by some 6 zeros. about 100,000 lakh, 10 lakh, 10 lakhs you can say, and this I make it as public, a semicolon. And thereafter what we do, we will initialize the contract with the initial supply of tokens to the creator of the contract. Let me write that. I put a hash star. I'll say I want to, oh no, 1 second, there is 9 has come over here. It is not 9, it's a bracket, I'm sorry. Initialize contract with initial supply tokens to the creator of the contract. And I put a star, put a hash. All this is comment. Now I create my function, which I'll call it my token. So I say my function, my token, which is which I would say is my brackets. No, it's my open bracket, which I would I'll say this is my token. And now this 1 second, where is that we have, yeah, this I would say I'll create my for this thing of this my token. Since it has to be double brackets, I would say, then I would open a curly brace, come down, I would say balance of a message dot sender, which is nothing but my initial supply, semicolon. And we close this. Basically, why did I write this line? I'm giving the creator all the initial tokens. So if I want to write a comment on this line, it is double slash. I'll say give creator all initial tokens. So this is a comment what I put. Close this. Now what I need to do, I need to send the coins. So after this, what we will do, we will send our coins. So I say send coins star and a slash, which is a comment. So in order to send coins, I have to create a function. I'll say function transfer of address underscore 2. There's a space after address, then underscore 2. It is not continuous, which is an unsigned integer 256 and underscore value. Close my bracket again. Then we would open a curly brace, a flower brace. Then now I have to check if the sender has enough. So for which I'll write require balance of msg dot sender, and this would be greater than or equal to underscore value. And this basically, why have I written? I have written to check if the sender has enough. After this, we will check for overflows. So to check for overflow, I'll say require balance of underscore 2, close my bracket. I'll add this with underscore value, which will be nothing but check my balance of and underscore 2. This will and I put a semicolon. This basically is to check for overflows. Then what do? I have to, after I send the money, I have to subtract this money from the balance of the sender. So for which I'll say balance of msg dot sender. This will be this value minus the value. So I cut short, I write minus equal to underscore value. This, why have I written? This is because to subtract from the sender. Then finally, what do? Add the same. Now, once the sender has sent it, I have to add it to the recipient. So for which I'll say balance of underscore 2. This will be this value plus the value. So this will be plus equal to underscore value semicolon. This is basically I want to add the same to the recipient. That's it. Now after this, and this is a very simple token what you can create. Extremely simple token that you can create. Done? Have you done this?
Yes, sir,
Yes.
done.
Okay, now do one thing, open Visual Studio on your system, copy this complete code into Visual Studio. Say you can save it as maybe say activity1.sol, because we will thereafter recall this. Save it as activity1 dot, or you can save it as mytoken.sol. Fine, we'll save it by that name, mytoken.sol. Save it as mytoken.sol. And then what you need to do for everybody, even for A, B, C, every section, please use Remix to compile your token. See, Remix is a browser-based Solidity IDE, which is the one which we are using currently. Among the features, you have various features like compiling, deploying, and debugging of the smart contract. So we will use Remix to compile our token. And in order to perform this, you will need a contemporary system with a current browser installed. So first thing, please check if your browser is updated. This is very useful. Otherwise, you will definitely have messages being thrown out. You definitely need to have your browser updated, and after that we can execute it. Click on this third button. The first is the compiler. See this one, compile this token. Click on the second button on the left hand side, click on the compile token.sol. It will compile it. After you compile it, click on the third button, deploy and run. That we will see. Where do you deploy it or not? We will deploy it and run it on the local machine. First you compile it, for which your browser needs to be updated. Once you update the contract, it will automatically show up over here. Like I'm getting this message, you have no contract instances to interact with. That is, if you compile this token, it will create an instance on its own. Uncheck this one, please, auto compile. Let it be like this. You have to compile it. Fine, this is, you can do it. So this whole thing forms one experiment for all three sections, A, B, and C. Incidentally, for section B, which we did other day, we didn't compile this. You can add up this to your code. Anybody done it? Fine. And one of the wonderful browser, which is a browser extension for deploying and testing a smart contract, is what is called as MetaMask. After you compile it, you can in fact deploy and test it test your smart contract on a MetaMask. Just Google it, MetaMask. So you will have metamask.io opening up. Open this, open the MetaMask, the original site, which is a crypto wallet and gateway to your blockchain apps. First, you need to download it, execute the contract, then you need to add a Chrome extension. It works well only on Google Chrome. Don't try it on any other browser. It has been preferred to run on just two browsers. One is Google Chrome, the other one is Brave. These two browsers only run on don't try to run it on anything else. You will be buggering up your system. You need to download it, and you get a window where you can execute your wallet file, which will be this one, which you have just created, compiled. Execute the wallet file and you can deploy your contract. Done. Your first contract is uploaded. So in any case, for section A, B, and C, we have done two practicals. For section B, one we did, I think, the day before yesterday, the second one today, on deploying a smart contract. Section A and C, you have done creating a smart token and deploying a smart contract. So these things, whatever small little story I told you, you need to replicate it on your lab record. Very essential for you. You may please see one small, I would say, if at all your system has got any personal information of yours, please do not download this MetaMask. Your entire information is will be made available to public. Unless otherwise your system you are using only for blockchain or deploying smart contract, Bitcoins, all this, then use it. Then fine, you can please go ahead. Download this MetaMask and you can do it. It's a free download. I'm not doing it because I've got a lot of my personal stuff on this PC. I don't want to take a chance. Have you completed it till here? Boliye, have you completed it till here? If you remember, we had shown you how do you create Ether and other thing. You can download the script MetaMask, transfer maybe 1 or 2 Bitcoin to your very close friend in your class.
Sir, this is done.
This is your downloaded this MetaMask.
Yeah.
You have to install it, and after that, do one thing: transfer 2 or 3 Bitcoins to your friend, and out of that 1 or 2, if you want, you can transfer it to me.
Sir, but I have an error in Remix.
Oh, then that's a problem.
Yeah.
You will not be able to do it.
Yeah.
See, comfortably, I could do it. See, when you're saying an error when you compile it.
Yes, sir.
Oh, that means it's a trouble. Just check the syntax of what you've written. Anywhere some caps and small will create big trouble for you.
So I checked it, but still I got an error.
It is
parser error.
Yeah. Yes, sir.
see, I'll tell you. See, there are 2-3 reasons if you're getting this parser error. One is your what is it? Your internet access. There's the Google Chrome is not updated. Second is you're using a slow connection. These are various reasons for which you get this error.
No, sir, I think it's a syntax error. It's saying.
It's a syntax error. So what we had written is this. This is correct. Maybe let me also check some small little thing maybe here and there, but it is more or less correct what we have done. Wait, let me just see. It is mapping address.
I think line number 8 balance off, there is a space in the variable.
किधर है भाई? Line number 8. Oh yeah, there is no space in balancer. That's correct. I wrote it like a normal English. There is no space. Small little mistakes here and there.
That I already corrected.
Uh,
I have error in fourth line.
Fourth line.
Yes, Anit.
Unint initial supply, which is equal. Where do you think? No, uint. Sorry. It is not unint. Uint. I'm sorry. Uint. My mistake. Unsigned integer. It is uint, which is unsigned integer. Oh, it's not unint. Sorry. My mistake. It's unsigned integer initial supply, which is the 10 followed by 6 zeros. I'm sorry. It's not. It's my mistake.
Sir,
Small little.
Is it same in line number 3? Address is equals to unint or
Yes,
uint?
it is unint. It is not unint. It is uint. Unsigned integer.
In 13 also, sir. Yes, sir.
13. Yeah, that's true. Uint. Small typographic errors. Okay, let me do one thing. Let me do justice of, you can tell me once you have completed this, let me do the justice of taking your attendance. 521013. 1059590. 1619169. 989832. 466905.
Yes, sir. Present, sir.
443952. 496596. 733011. 15001. 15002. 15003.
Yes, sir.
15004.
Yes, sir. Yes, sir.
15005.
Present, sir.
15006. 15101. 15102.
Yes, sir.
15106.
Present, sir.
15107.
Present, sir.
15108.
Present, sir.
15110.
Yes, sir. Present.
15112.
Yes, sir.
15113.
Yes, sir.
15114. 15115.
Yes, sir.
15116.
Yes, sir.
15118.
Present, sir.
15119.
Yes, sir.
Rituraj Singh Rathod.
Yes, sir.
Then 151022. 151024.
24 present, sir.
151027.
Yes, sir.
151028.
Present, sir.
151029. 151030.
Yes, sir.
151031.
Yes, sir.
151035.
Present, sir.
151037.
Present, sir.
151039.
Present, sir.
151041. 151044.
Yes, sir.
151045.
Yes, sir.
151048. 151001 LA.
Present, sir.
151002. 15 Aniket Charanya. Harsh Damecha.
Yes, sir.
Anand Godani.
Yes, sir.
Kavan Prajapati.
Yes, sir.
Then Rushi Kanjaria. Kishan.
Yes, sir.
Mohil Balani. Parth Pokar. Vinod Rathod. Rikin. Meet Safsani.
Present, sir.
Sitanshu. Tilak Ved. Paras Bhai Viradia,
Yes, sir.
Abhishek Trivedi, Chintan Lakani,
Yes, sir.
and 151036.
Yes, sir.
Fine, that's done. Anybody whom I missed out?
Sir,
Sir, 14.
29 and 39 both are here, but their mic is not working.
Okay, what's the
29
number?
and 39.
20.
151029 and 151039.
151029. So 29 is okay.
So
And
14 also 1510.
And 39, sir. 392.
Yeah. 39. Okay.
So
Okay, anybody?
151014.
151014. Okay, anybody else? Wonderful. So please execute this, what you are doing on this MetaMask remix and MetaMask. Compile it. Have you been able to compile it?
No, sir, there is still an error.
What error?
Yes, sir.
In line 4, it says the public की जगह पे semicolon expect कर रहा है सर.
Yes, sir. Same.
Public की जगह पे
error.
semicolon, or is it after public? After public there is a semicolon.
नहीं,
Yes,
पब्लिक
sir.
के जगह पे सेमीकोलन
It
एक्सपेक्ट
No,
says
this is
expected semicolon but got public.
हाँ, गॉड पब्लिक ये
This is 100%. Do one thing, fine. For the sake of it, एक बार public हटा के just use a semicolon and see. You will encounter error. That's the problem. See, this has to be public. This is unsigned integer, initial supply, this one, 10 lakhs, whatever, and it's public. You have to make it public. How can it be without?
पब्लिक हटा रहा हूँ सर मैं, तो एरर नहीं आ रही है.
नहीं, but और कौन से लाइन पे आ रहा है एरर फिर आपको?
फिर पब्लिक हटाने के बाद जो फंक्शन माई टोकन है, वी आर
Function my
क्रिएटिंग, यहाँ पे हम कंस्ट्रक्टर बना रहे हैं, तो वो बोल रहा है कि फंक्शन का नाम और कॉन्ट्रैक्ट का नाम सेम नहीं हो सकता, तो उसको
Oh, 1 second. इसमें my token, sorry, this is a mistake. यहाँ capital T है, not small t. अभी मैंने देखा, so sorry, it has to be capital T. ये सब छोटे मोटे typographic errors.
It's error.
And here also it is not though T, it is single T. Unsigned integer 256 space underscore value. Require balance of msg.sender greater than or equal to underscore value semicolon. Okay, and chote mote small little errors here and there. Underscore 2 bracket close semicolon. Okay, balance of msg.sender minus equal to underscore value. Subtract from the center plus equal to underscore value. बाकी all I think is fine. अभी एक बार execute करके देखो आप.
No, sir. It's error.
कहाँ पे error आ रहा है? Where are you getting the error?
Function my token.
Function line number 13 you're saying,
Yes, sir.
or line
And,
number 7?
7 and 13 both.
Function my token, it's correct, it's very correct.
Excuse me, sir.
Yeah.
Sir, I have compiled it successfully and I'm getting some options. Publish on Swarm, publish
Wonderful.
on IPA.
When one of you see, it is a small little typographic error here and there, and you have published it through MetaMask.
No, sir. Actually,
Same
I
thing.
don't want to download it.
No problem. You published it to the same remix only.
And I don't know, sir, how to publish it.
Okay, I'll tell you how do you publish it, and after the class you can please advise all your friends. What it's a small little typographic error here and there. See, you created your token, and what's your name? Who has just told you published it?
Sir, Harsh Dhamecha.
Harsh Dhamecha. Okay, Harsh is on the thing of publishing it. For you to publish it, what options are you getting?
I'm getting 3 options. Actually, to publish on Swarm and publish on IP address.
See, if you want to publish on IP address, you need an internet connection on your own where you are able. You need to be an administrator. Use the first option and publish it.
Okay.
Excuse me, sir.
Yeah.
Sir, do we need to make these two functions as public, sir? My token and transfer?
Yes, it has to be public. See, if you don't
Yes,
make it public, how is that you're sending money to somebody?
So in this course, sir, you need to do it public, sir. We have
कहाँ पे?
missed it. दोनों फंक्शन के आगे पब्लिक लिखना पड़ेगा ना सर, ट्रांसफर और माई टोकन.
Transfer. Which line are you referring to?
Sir, 7 and 13, where we are defining the function names and all.
No, that's correct. This function my token fine. I'm creating a function. See, don't worry. That which you say public, upar do line mein khali public hai. That's more than enough.
No sir, then it's showing an error.
Ask your friend Damecha, who was just now
तो
executed.
उसने वही किया है सर, यहाँ पे पब्लिक लिखा है तब रन हुआ.
कहाँ पे? Function my token के सामने.
माई टोकन के बाद में
हाँ
पब्लिक
सर,
लिखा.
हाँ हाँ.
That means you're telling line 7.
Yeah, line 7 and line 13. Both places. Yeah.
Function transfer, and here also you say you have written public.
Yes,
And
sir.
this is what you have done, Harsh.
Yes, sir, exactly.
1 second, wait. Yeah, fine. ये करके have you been able to publish it?
Yes, sir. I got one pop-up where some details was mentioned, like JSON and one another message.
Yeah, that's it, fine.
Successfully published.
You are successfully published. You have created your first smart contract. Do one thing, Harsh. Right now, since you're on this chat where you can speak to whole of your class, just have a word with everybody. Tell them what did you do.
Yes, sir. Yes.
All yours, Harsh.
Actually, sir, I have pasted the code in chat box, so everyone can just copy and paste it in their
Yeah.
window. You just need to put public after the function definition and remove the public from fourth line and do one thing, that make it uint instead of unint.
Yeah, it is unsigned integer, uint.
Yeah.
See, all these things, my suggestion is when you replicate on a lab record, rather than writing story, take a screenshot of all this and put it in that. So Harsh, you can once again go back into creating token. Then where did you compile it? You take a screenshot. First token ka screenshot le lo, take a screenshot of your compiling and you're executing it, deploying it. Uska bhi you take a screenshot. All these 3 screenshot, you can put it in your lab record.
Yes, sir. Sir, actually, after publishing it, how we can deploy it?
No,
Or
you
is
see,
it-
to deploy it, you need to deploy it on the internet, for which you need that rights.
Okay.
This you're deploying it on your local machine. This is a demo what you're doing. You cannot, it is not that simple deploying a smart contract. See, but when you say now, like say you want to deploy some government contract on the website, it's a big process, very, very big process. And this, what we have written in this token of say about 5 to 10 lines, it's totally different from this. It'll have hundreds of lines of this kind of way what you have written.
Okay, sir. Okay.
This is you have done, just deployed it on a local machine. That makes no difference. All of you have copied whatever he has given it to you, Harsh Damecha. Run it on your system and see yourself, please.
Yes, sir.
Yes, sir, done.
Fine. Take a screenshot of everything, put it in your lab record. But friends, please understand, all these things which you're doing is not as per your syllabus. It does not figure anywhere in your syllabus. But I felt learning blockchain without doing all this, what is the use? So we're doing something really interesting. Fine, all of you have done it?
Sir, there are 2 options, publish on Swarm and publish on LPFS. What are these?
Publish on Swarm. See, the second option is for you. You need internet privileges for you to publish on the net, which is the right way of publishing any smart contract.
So for now, we need to publish on Swarm.
Yes, that's right. which will publish it on your local system. Because once you publish on the public domain, the whole of the world can see it. Harsh, do one thing. After you do all this, go to this page, सबसे नीचे, this deployed contracts. Are you able to view your contract?
Yes, sir. I've done that. I'm able to see that.
Yeah, that's it. Take a screenshot of even that one.
Okay, sir.
Fine. All of you done? Even viewed your contract which you have published?
Yes, sir.
Yeah, take a screenshot of even that.
Yes, sir. Done.
Take a screenshot. So you'll have multiple screenshots for this experiment. The first one being when you created a token, then when you compiled it, then when you have deployed it, and then when you view your deployed contract. And the writing part of the story I had shown it to you on this whiteboard. What do you write? So you can put all those masala in this and prepare your record. Don't worry, section A and C have been little more lucky than section B, because for section B we never did all this. The time was already up, so we could not do all these things. Have all of you done this?
Yes, sir.
Yeah, fine. We are at the end of the session. Unless somebody wants to ask me something, we pack up. Anybody, anything? Wonderful. Thank you. Have a nice day.